clip it, clip it, clip it, clip it. Ooh. Clip it.
I've always tried to keep a low profile, sitting on the bench being lousy at my style.
Today we're making one of these phone clips or phone holder, whatever you want to call it, or like these tripod stands. These things come off. These things are really useful. They hold your phone. I'm sure you've played with one before. This is the one I usually use. So right now, for you entitled suckers who are watching this, I had to tape my phone against the wall. The things I do to show you I love you. But we're over here. So yeah, we'll be making one of these. And you ask, well, hey, how are we gonna do that? Perfect. This is what we're talking about. So last time we talked about making a 3D scanner. And I told you I wanted to use just a normal phone to do that, my phone camera. So what we need is a way to hold the phone in place while we move it. And I think that's gonna be the most complex mechanism that we have. I know that's kind of weird. Now, we could just fix the phone on there. We could just tape it or something like that. But I really wanted it to be modular so anybody could put their phone in here. I have this old dinky phone here that I used to use, and it fits in here, and it's wider than my current phone. And I think that that's kind of cool that we could have something that anybody could use. But because we're gonna have to using the spring action, I keep losing the spring. I can't believe this. Like, I need this spring. This spring is critical to the project. Did you take the spring? Where'd the spring go? Oh, you're so cute. You probably took the spring. I took the spring. I spent the last hour looking for this spring. Now it stays on this magnet. I feel kind of bad. I said some mean things to my cat. He didn't deserve it, but it's not like it wasn't motivated by anything he's done in history. He'll get over it. I found this spring out of like an old printer. I think that's what it came from. I don't know. I went to DI or Goodwill and I must have bought a printer. I do that a lot to get like scrap parts and stuff. And I thought, hey, I could probably use this for something. So when I was thinking about making one of these like phone holders, I was looking at the mechanism on the other one that has these bars and you kind of pull it and then it pushes back somehow. And I was kind of thinking about it's obviously a spring, but like how kind of mechanically to do that. So I used this spring in my design. We're gonna be making this. I made this, I designed this, so it can fit on my 3D scanner that I'm designing. And this is cool because it fits the phone with the same idea and it'll work just like this and it'll hold it in place with the spring. All right, what you're looking at is not quite the finished version, but it's the version of a phone holder that I designed that you can stretch and move this top portion over to clamp your phone. So I'll take this old phone out and you can see that I've got the spring installed in here. I'll take that off. If I move this up and down, then it will pull this back with some force to hold the phone in. And these pieces all come out because I haven't fastened it together yet. And I did that just so you guys could see. And eventually I'll cut these bars as well. But this part, we'll get into the design of this, was designed to interface with the 3D scanner so that it can hold the phone while looking at the object in the ring. Because we talked about building it with a ring design. It's pretty neat. It's a pretty neat design right here. I like the springiness. I like how it moves. The 3D printed part is a little bit, it's got a lot of friction, so it doesn't open super easily sometimes, but with some sandpaper and maybe a bit of finishing work on the print, I'm sure I could get this to open a lot better. And I'll talk about the methodology kind of mechanically that I was thinking about in Fusion. I plan to break this whole build up into kind of 3 parts for the mechanical section. This phone holder does kind of have some more complex geometry, and I kind of want to start slow so you guys see just the whole design process there. And then as we break up into more parts after I finish this kind of phone holder design, I'll show you the 3D model of the scanner and how I built that itself. I might not take as much time that I take there with this, just because by then maybe we'll get on board a little bit more kind of inherent CAD design. And the last part will kind of show what it's like to print these pieces and assemble it and how the build actually works before we move on to the mechatronics and software side of this project. So let's go design this thing.
The man, he felt the smack, I said, this here's my turf. Nobody that don't got a permit.
Mine's the time jump. Okay, getting started here. Opening Fusion. Now, we're going to navigate to our project folder here where we're making the 3D scanner. All right, we're gonna create ourselves a new part, and we're going to create ourselves a sketch on the base plane, And we're going to be making the spring first is where we're going to start here. So I'm going to create kind of the height of the spring, which I've measured this out to be about, it's 36 millimeters, I'm working in metric. We're going to change the units so that those align. And then, oh yeah, we got to save and name the project. So we're calling this the spring, I don't know, it has an 8 millimeter OD, so we'll call it that. And it's 37 millimeters. It's not perfect. Close enough is good because the spring needs to be under compression a little bit. And we'll create the base of the spring with the circle representing the outside. And we're going to use the coil tool, if you're familiar with that. And I found that there were, I think it's 13 revolutions on the coil. Double check that, it's 11. We're going to kind of play with these things. It doesn't matter if the spring is perfect. It just needs to be a good model to kind of help us reference based on that. You wouldn't want to 3D print this spring. You'd want to find a spring of your own. I might leave a link in the description to a spring that's similar that I can find. Or if you have anything else laying around the house, design it to your own needs. The section size of the spring, the diameter of the spring itself is half a millimeter about half a millimeter. And there you go, we got a pretty good looking spring. If you've ever used those tools, you can play that back. Looking around the spring, there's a portion of the spring at the top and bottom that are a little bit shorter, where they kind of taper off. So most of the spring has a kind of uniform distance between each coil, but at the top you have 1 or 2 coils that are shorter. So we'll look at the face here of the spring, and we'll create another coil. Coil tool is kind of weird. You can't just build it on a sketch. You have to build it on a plane and then move the coil that you make to that plane. So we're building a plane on the sketch where we want this coil to be. We'll use the same diameter that we use, and we'll just give it about 1 revolution, a little more than 1 revolution maybe, to create that kind of offset tapered portion of the spring here. I'm getting a couple errors because it says that the radii are too small. It'll work when I get these parameters, kind of play with them a little bit. So yeah, well, there's 1 revolution. Now we'll move this guy so that he's in line with the previous coil there. We'll have to edit the feature a little bit. Make it a little shorter, it's a little too tall. Then we'll move this coil onto the other coil like that. And then we'll do the same on the bottom, so we can kind of speed through that part right there. Creating a sketch, creating the plane for the sketch. Grab the coil tool again, creating the circle for the coil tool. It's going the opposite direction it ought to be, so we're going to reverse that. Then I'm going to set the section size again to half a millimeter and make it a little over 1. 1.2 revolutions seems good because it kind of overlaps a little bit, which I noticed that my spring does. Then we'll align the bottom coil again to the face of the entire spring. This is my method for making springs. If you really want like a really tight, robust spring, there are better methods than doing this. You might create your own sweep with your own path. I prefer the coil tool because it's simple. It removes a lot of the overhead. Now we'll combine the bodies to make them one. So we selected the 3 bodies and use the combine tool. So now they're all 1 body. I'm creating a few planes to use for adjusting when we create joints and make things kind of fit together. So I'm creating a plane at the top of the spring and at the bottom of the spring. It's okay if it's not perfect, just somewhere near the ends of that. And this is so that we can place the spring easily and align it, because you use planes when you align and you make joints. It's hard to do a normal plane to a round surface that tapers as it goes up or down. So that's why we have these planes. So yeah, there we have the spring. I think it looks pretty good. It's pretty close to what it is like in my real life model. And I just realized that it's backwards from mine. The one I just designed goes counterclockwise, and the one that I have turns clockwise. So we'll just mirror the part real quick, and we can hide the other body or delete the other body. We'll use the one that turns clockwise. like that. There we go. So, yeah. There we have it. Pretty nice looking spring. Now let's jump over. Let's create a new part for the body of the phone holder. Okay, so we got our new design. Name it real quick. Phone holder. We are going to insert what we just designed into this model. It's kind of like a master modeling mode where you take parts and you build them with other parts in the same kind of assembly. So we imported the spring here, and this is where those planes will be helpful that we had on the spring, so we'll know how to reference, what the true top and bottom are for where we want the spring to be contacted. So we'll look on the construction planes that we had for the spring. We'll do the first at the top here. What we're going to be doing is creating these little inserts that go into the spring that go into the inner diameter of the spring, and we'll keep the spring centered on top of it. So we're going to create a circle that kind of goes within this that has some kind of tolerance, about maybe a 1 millimeter total for the OD of that, and then the ID of the spring will be able to move along that, but probably fit kind of snug with the 3D printer tolerance of this piece that we're making. We'll pull this through a few millimeters. 3 millimeters sounds good. We only need like an inch or so of play, maybe like 2.5 centimeters of play. And we'll move this, we'll pull this the other way as well, so that there's something for us to build on for the base part that this will attach to. This will make sense. We keep going. So the spring will kind of wrap around this. You'll loop it through some of the coils so that it will rigidly hold on to that piece there. And we'll just mirror what we did above for the bottom. So we'll have those two bodies right there. Next, we're going to work kind of on the body of the clip so that we know where these things should align. I've measured out the one that I had currently to be about 38 millimeters wide. And I'm going to center this spring in the middle of this. So we'll make this symmetric about that construction line I put on the origin. Then we will kind of create some geometry that will key these ends that I've made for the spring holder attachment. So I put down some lines. I'll use some constraints to make these things collinear. You can see that there. A lot of symmetry constraints because I just want this rectangular bit that's going to slide in and out from the front face. So we kind of give it this geometry. I don't know, I'm really just kind of eyeballing this. I know that you can make features about 1 or 2 millimeters on the 3D printer. So we'll give that a 3 millimeter height right there, and we'll make this about 20 millimeters wide. Then I'll make that a centimeter wide right there. And we'll make that another centimeter wide right there. Yeah, looks pretty good to me. There'll be some tolerance to play around with it. We'll just make things a little bit better here. Give a gap right there for this rectangular portion. Oh, and the height of the whole thing was I think also 50 millimeters. We'll make this symmetric about the middle of the spring as well. And we'll mirror that down so that we can have both those features on the top and bottom. Now, this will kind of create the core feature of our phone holder right there. Yeah, so next step would be to make sure that this is aligned in the middle of the spring. Then we'll go ahead and we'll pull these faces and we'll create the first instances of the body of the clip, the phone holder. There we go. So we're looking like we've got something there now. We'll pull the other side down and we'll give that 2.5 millimeters. So it's up a centimeter, basically, with 2.5 millimeters on the base right there. Now we're going to create another sketch that's going to inlay to this clip that we've made, like I said before, for this rectangular portion that these circular bits will connect to. We'll offset about a 0.5 millimeter. Found that kind of works on the 3D printer. And then we'll pull these rectangles up and combine them with those circular portions that we made that go through the spring to match in line a little under line of the face by maybe 0.2 millimeters of the top of the clip. So yeah, now we're going to create these rods that go in to the base of this phone holder that are used to kind of manage the sliding action. So these steel rods, they're 2 millimeters wide. You can find these anywhere on Amazon, like MasterCar. Very easy. You might even have some sort of equivalent laying around. You can make these whatever size you need. I just create a circular feature. We'll pull this to about the length of the body, or a little bit past it. The ones I have at home, these are 100 millimeters. So we'll probably pull there to 100 millimeters. Don't forget to make your units in millimeters here. Yeah, so here's a rod, basically. Doesn't really matter what it looks like or material-wise. We'll call this the steel rod, 100 millimeters, 2 millimeter OD. We'll go back to the phone holder, and we're going to insert this part as well. It's important that you save your parts if you want to insert them into other ones. Otherwise, Fusion will give you problems. So yeah, we'll insert these rods. We'll put 2 of them in there. And these will act as kind of sliders that guide this phone holder so that the spring stays aligned and it keeps the body rigid. The 3D printed plastic's not that great when it comes to being in constant forces. So we'll put the force of the actuation along these rods. So we'll align these rods with kind of where we think would be best to kind of keep the distance away from the phone. It's going to be, in this case, inside the phone case holder part, so it's not exposed. We're going to create some kind of divots for manufacturing here that you can place the rod into, and then on the other side we'll put something you can slide the rod into. I'm creating this kind of L shape because I want to see if we can bend the rod a little bit so it doesn't have to poke out like on the version you saw. I'm not sure though if I can bend that steel at this small an angle. I don't know if I have the proper tools, but I'll print this feature and add this anyway. So I'll just kind of play around with the idea here. I'm using 0.2 millimeter tolerance between the walls, 2 millimeter wide wall, and 2 millimeters away from each wall. They're just nice clean numbers, and it looks like it'll have enough material between things to at least be rigid enough to not break during use. So yeah, there's one. We'll just kind of cut that down to a level where the rod will be still suspended from the base, but it's deep enough that, you know, when I put a cover over the top of it, the rods will be hidden behind the cover. So yeah, that looks pretty good to me. We can just mirror this feature over. So you can mirror features, not just bodies and components. If you grab the feature from the timeline or from just the faces of the last object you did in the plane, and you can see we cut it here on the left side as well. Now we're going to create a sketch on that face right there where we just made those cuts because it's square and it should be round like the rod. I'm going to hide that body right there just so I'm not highlighting things, but we'll create some circles in these holes where we projected the geometry. We'll just make them tangent to both the walls and the bottom part, right, like this. We'll try and do like a sweep so that we can get the whole L shape in one go that matches the geometry. So I created a plane that's in the middle of that circle that I made, and then I'll put a right angle line that's in the center of 2 right angle lines that are in the center of the width of this cut that I've made. As I'm using the midpoint constraint there, you can see by clicking on the line and then clicking on the body or the projected lines, and then we'll put a right angle on there. So yeah, we have these 2 lines, and we'll sweep the cuts of these corners through those lines that I just made on that face, and that'll give us a round bottom in both of these things. We'll do that on both sides. You could also try and mirror this feature like we did before, but I'll use the sweep. More complicated features I tend not to try and mirror, as sometimes they can break on reconstruction down the road. So we're going to create a face on the opposite side, adjacent to those faces, where we're going to put circular cutouts for the steel rods to go through. I just projected that round geometry from the other face onto this one, and then I'm kind of thinking we put a rod, and then we'll extend that rod cutout hole kind of through the face there so that there's more supportive material for the rod to hold onto. That's why you kind of see the square geometry below it. Putting a tolerance of about 0.2 millimeters again, 1 millimeter. Oh, I think I did 1 millimeter here, yeah. And then I gave it kind of the larger OD out, the extra material on the outside is 4 millimeters, and we'll mirror this feature over to the side. And then the lines at the bottom are just right angles straight down from the tangent sides of that 4 millimeter circle. Yeah, so it looks like this. I added these cutouts at the top, just thought it would be easier to get the rod through there so you can see the rod going through if it gets stuck somewhere, and it'll be a little bit compliant so that if there's tolerance issues here, shouldn't be a problem. And so I'll line the rods with those holes that I made, and you can see kind of how they work there. I aligned them concentrically, and then I aligned them to the base that I cut on the inside of that face. Looking at the rod now, I'm gonna try and add the L-shaped geometry to the tip of it so that it fits in the phone case holder, so it doesn't stick out like this. and I'm kind of going back and forth to make sure I have the measurements correctly referenced in the phone holder to add this kind of curve geometry to it. So we're creating the L shape, and we'll give it, well, I guess I need to cut it back. Yeah, so it's a right angle. We'll give it 1 millimeter. Since it's 2 millimeter diameter, we're going half down the millimeter. And then, I don't know, it goes about 2.5 millimeters to the other wall. So we'll do 2.4 here, just so there's a little bit of gap. And then we'll cut down the rod, make it shorter because it's too long. And we'll do that by creating a plane at that point that I just made back in there. Then we will create kind of a radii on the inside of this so that the transition of the bend is smooth, and then we'll sweep that face of the rod through that. And there you go. When we save it and we update it and we link it in the model, you can see that it has that curved geometry now in the model. So yeah, so far so good. You might wonder if this doesn't move, it's all one rigid object. Well, we're getting there. First, we're going to create some cases on the top though. So I'm going to look at the bottom portion of here first. First, we're going to project this rectangular face of the bottom. You can see I made these cutouts. I decided it was not a good idea. I removed that part of the video. They were supposed to be a way for those cases on the top and bottom to fit through some holes that go into the base, but I realized that the case itself is pretty rigid and I'll just screw it on afterwards if it doesn't fit well. So ignore those cutouts. The case of the top and bottom are 2 millimeters itself. And I created these divots that go over the top of where those rods fit in on that side, so that when the rod's in there, it's holding the rod against the base. So I gave that another 0.5 millimeter tolerance on both sides of that and brought it down to interface with the geometry of the rod, as you can see. Then we will I make a case for the top part, so I made a case for the bottom part. Now we're making a case for the top part here. I kind of made some slots so you could see the rods to the top of it. It just matches the geometry of the case with some overlaps on the sides that go past those rods on the left and right. It's also 2 millimeters thick. Here's what it looks like for now. We're doing the side geometry where the phone holder sits. I measured these out to be, the gap is about 44 millimeters, and these are also themselves about 1 centimeter. I'm adding a gap for the phone to fit in, so that should be centered in these portions too. Then we will cut that and slide it so that it's something that can hold the phone, but we'll soften up all these edges so they're not so rough with some fillets, and that'll make it more manufacturable and make it more likely to not break, and it'll be a clean and clear model. Giving them a millimeter, 1.5 millimeter edge, whatever I can give them without it being too unreasonable. And then I'm cleaning up some other areas of the model. So yeah, here we have just one kind of rigid thing with several case bodies, but the thing doesn't move yet. We'll have to cut it. Let's make it all white so that it's pretty. You can see the different bodies. So now that we have the 3D model basically there, you're saying that the body's still all one piece. So what we're going to do is we're going to create a sketch that separates these two pieces so that they kind of work together. My idea here is, if you look straight down, we can carve out kind of a block piece behind the spring that attaches to the top part, and then the base with the rods threaded to these holes will make up the bottom part. So we have like a sketch that kind of defines that very loosely, and I kind of already did this, so we can roll forward here and you can see that I've cut pieces out of the top and bottom, so you have kind of this suspended feature, and the top and bottom cases are already separate bodies, so it doesn't really matter. And we can advance this forward, and you can see kind of these different cuts that I made on top. It got kind of messy trying to think about the logic of it, but when it ends up and you come with the nice pieces for this design, this is what the final result kind of looked like. So we have a separated top piece that kind of latches back. I extended this sort of portion out just a few millimeters here to attach to this kind of top sliding piece, and then it wraps around here with a sliding bit, and then they kind of interface with each other. And to see how that looks, we'll create joints for it, because it's not super intuitive just looking at it without the motion. So rolling forward to this, we'll hide these case pieces for the top and bottom, by the way, which we added lips on the side to kind of go over the edge, to kind of hug it, to give it more something to grip when I fasten it. If I use glue or nails or something, just a lip to put that through. And then when we add the joints, and we'll hide these like I said I was going to. I added these sliding joints here so that you can see what happens when this piece moves to compress the spring. It would get pushed back down, and they don't interfere with each other, like that. With the model pretty much ready to go, we can roll back to the front here. We can see the beauty in its holy essence. And I made more of an overlap at the top and bottom for these to properly extend over the base pieces so that it can still slide, just like we had before, but these pieces can be fastened together a little bit more nicely. I also made through holes for the rods on the top portion so that in case that the L doesn't work, there's a place for them to go through. With the model nice and ready to go, let's watch from the beginning.
Up here, this here's my property, son. You better get stepping. This should be fun. I'll break your face, then I'll snap your neck in 7 different places. I got friends in the mafia, and if you fight back, I'll stop you. I'll break your face, then I'll snap your neck in 7 different places. I'm a black belt in Kung Fu. If you wanna fight, I'm down. Let's do this. All night fire burned the town. Bad guys running around.
So here we have the phone clip in most of its glory. That might have been kind of fast for you. If you have questions, let me know. Really, I'm just showing you how it's made. If you really want to know about Fusion, there are perfectly good tutorials that will teach you how to do that. But next time, we'll talk about the design of the 3D scanner and the geometry on the phone clip that goes against the 3D scanner. And then we'll talk about the gears for the 3D scanner and how that's going to interface with the motors. And then we'll kind of show you how to make the joints for that and animate that. And then hopefully we can get that started, printed and made, and see if it works. I'm still new to making videos, so I know some of these things are kind of rough. If there's something you like or something that you'd want to see more of, or something that you think I'm not explaining well enough, please let me know and I can prepare more or take some of things out. I might be going into too much detail. Maybe you want to hear me talk less and you just want to see things in action. That's totally cool too. Just like, subscribe. Really help me out. Let me know in the comments any thoughts you have, and I'm your guy. I'm there for you. These models will be available in the future when I get the whole project done. And if you'd like to kind of make your own model, you can follow along here or take your own idea and share it with me. I'd love to hear about it. But until next time, we'll see you then.